Hi everyone, thank you for having us today. And we're going to talk about instrumentation and data collection of the physical experiment model that we built for our class. We are team number 6, and we are Acatzin, Benítez, Salgado, Ximena, Icela, Gómez, Tagle, and Cesar, David, Nolasco, Mendoza. We're studying biomedical engineer in the Universidad Autónoma Estado de México, and we're going to present about our project. Well, here we have a couple of topics that we are going to develop during this presentation. The first one is motor and boards properly mounted on the platform. The second one is instrument motor capable of being activated from the board. Number 3 is acquisition on serial transmission of the motor step response data in radians and seconds. And the number 4 is table of acquired data arranged in 3 columns, time, input, and response. And the last one, number 5, is graphs of data obtained, graph of the input and the response. Okay, well, talking about the components that we use during this experiment. The first one is the motor. This is a GM25370 model that has an encoder and also a grid box. And this is really important because this motor has 140 revolutions per minute, and the gearbox is working with a relation between 1 to 45, and we have 495 pulse per revolutions, and we think this is a great component to this experiment. Also, we are using an Arduino One to make this possible, to create all the programs and to make the motor start working. And last but not least, we are using a driver, H-bridge, and the name of this driver is L298N to control the motor.
The motor has two coil connection pins which are connected to output 1 and 2 of the H-bridge. Two encoder power connection pins connect to 5 volts and ground. It is very important to connect all the grounds in common. Two data acquisition pins of the encoder are connected to digital input 3 and 4 of the Arduino. The H-bridge is powered with 12 volts and the input marked 12 volts ground and 5 volts of the Arduino. The digital pins 8 and 9 configured as output are connected to input 1 and 2 of the H-bridge. The first video shows the input data of the code in which we enter the sampling time and the period to sample. Finally shows the motor speed. We made a small modification in the code according to the resolution of our encoder. In the second video, the rotation of the motor is observed once the code has been executed.
Okay, now we're going to talk about the part number 4 that corresponds to the table of the acquired data. Well, as we can see in this part, we have the table that is arranged in 3 columns, and the first one corresponds to the time that is of 600 milliseconds and divided in samples of 5 milliseconds. Then we have the input or the voltage column that is in 12 volts, and finally The third column, that is the response or velocity in radians per second, that this column has the values that we get from the model data acquisition. Finally, we're going to talk about the part number 5, that is the graphs of the data obtained. Well, in this graph, we can observe two signals, the input signal, which in this case is the step signal, and the response signal, which is the velocity. On our horizontal axis, we have the time, that is in seconds, and as we can see, is divided according to our sampling time, which is in 5 milliseconds, and reaches the end of the acquisition time, that is 600 milliseconds. And on the vertical axis, we have the voltage, which is in volts. And finally, as we can see, the transitory state and the steady state of our signal are evident. And that's all from our side. See you in the second part of this project.